16 and 17 I'll do together. 16 is from a TI-80 plus graphing, TI-84 plus graphing calculator. 17 is from a Minitab, but we're asked the same question. Do you reject the null hypothesis, H sub 0, at the alpha equals 0.05 level, at the 5% level of significance? Okay, so there's two approaches that we probably discussed about hypothesis testing. There's the traditional method, and I'll show both, the traditional method, and then there's the P method. So the traditional method, and then the P method. And from these outputs, because we're given all this information, we can use either method, either approach to determine if we reject or do not reject the null hypothesis, H sub 0. So I'm going to write out what the null hypothesis and the alternative hypotheses are, just to review. Here, the null hypothesis, the statement of equality, is the mean equals 60. The alternative hypothesis, HA or H1, is that the mean does not equal 60. So that's the statement. So we're going to either reject or not reject this null hypothesis here, that the mean is equal to 60. Population mean is equal to 60. So the traditional method, essentially we're comparing, so we're finding the z critical value, right? We find the z critical value. And using that critical value, we determine our critical region. And we check to see if this test statistic, this z value here is our test statistic. We check to see if that test statistic falls in our critical region or our rejection region or not. So let's find the critical value, right? The critical value. So if alpha equals 0.05, I'll draw a little something here. This is going to be a two-tailed test. How do I know that? This is, the mean is different from 60, or the mean does not equal 60. So that can happen in either of these two sections here. So in order to find that critical value, I need to divide this alpha by 2, because this region is going to be 0.0. Let's erase that. 0.05 divided by 2 is 0.025 and 0.025. So each of these regions here is 0.025. I need to go to the table, the z distribution table, standard normal distribution table, to determine which z value gives me this percentage to the left, this area to the left of 0.025. So I go to my z distribution table. I'm looking for an area of 0.025, and the z value that gives me that is negative 1.96. So here, negative 1.96 on the left, positive 1.96 on the right. Yes? So I'm going to redraw this a little bit larger here. So here's 1.96, here's negative 1.96. And that's my critical region. So what the traditional method says, once we determine that critical region, right, we calculate our test statistic. If our test statistic lies in either of these regions, what I'm saying is, if the test statistic is greater than 1.96 or less than negative 1.96 for this two-tailed test, if it falls in either of these two regions, reject the null hypothesis. Otherwise, don't reject the null hypothesis. So, here's my test statistic. This is my z test statistic. 1.06, let's just say 1.07. 1.07 is somewhere here, isn't it? Right? If my mean is in the center here, that's my mean, that's 0, right? That 1.07 does not lie in either of these two rejection regions, because that test statistic does not lie in each of these critical regions. Do not reject h sub 0. So the answer to this question here is no. That's the traditional method. Again, determine your critical values, your z critical values if you have two tails, or your z critical value if you have one tail. Once you determine that critical value, you'll also get that critical region. Take your test statistic. In this case, it's nice because we're given the test statistic for each of these, right? We're given the test statistic. If your test statistic falls in either of these two regions for two-tailed, or falls in that one region for one-tailed, then you reject the null hypothesis. If your test statistic does not fall in that region, do not reject the null hypothesis. Now, using the P method, I should come to the same conclusion. I must come to the same conclusion. P method is I think it's a simpler method to use when you have all this information. The P method says this. If your p-value is less than or equal to your alpha, reject the null hypothesis. If your p-value is greater than alpha, do not reject the null hypothesis. That's it. That's it. That's it. That's it. That's it. P-value. P-value. It's given. 0.0. P-value. 0.28634. I'm comparing that to alpha. 0. Comparing that to alpha. 0.05. What symbol goes there? Is this less than that or this greater than that? Looking at the common positions, the ones place is both 0. 10th place, 2 is bigger than 0. 2 is bigger than 0. So 0.286354 is larger than 0.05. My P is larger than alpha. Do not reject the null hypothesis. I come to the same conclusion. Either method you use, do not reject. Now I'm going to carry this thinking down. We're going to do the exact same, both methods, for this next situation. And again, what we're really looking at is the z value, the z test statistic, and the p value here compared to alpha. So let's see what's happening. So the traditional method. Traditional method versus the P method. Let me give myself a line here so I know. Yes, 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 yes. Okay, so here's our test statistic. So let's determine what we're looking at here. Is this a one-tail test, a two-tail? Test of the mean, so HO is the mean equals 33. Alternative is the mean does not equal 33. This is another two-tail test. This is another two-tail test with my critical region being critical regions, right? Alpha is 0.05 again. Yes, this is a z-test, so just like before. So if alpha is 0.05, just like before, each of these regions is 0.025. And just as we calculated before, that critical value is negative 1.96 and positive 1.96. If alpha was 0.01 or 0.10, then we would have to calculate again. We would have to go back to the table and do all that. But we don't this time. Z-value, test statistic, negative 3.04 something, something, something. That is over here somewhere. Let's go even further. Yeah, we could say it's over here. Somewhere over here, right? Negative 3.04. That is definitely all up in my critical region. That is all up in this critical region, isn't it? Negative 3.04 is less than negative 1.96. It's in my critical region because that test statistic lies in my critical region. It could have been positive 3.04, whatever. Because that Z test statistic lies in my critical region, reject the null hypothesis. So do I reject? Yes. Now let's check the P method and see if it works. Let's check P. P is 0.02355. Alpha, 0.05. Let's check which is larger. Zeros are the same. Here 5 is larger than 0. So this is larger. So my p-value is less than alpha. I always write my p-value first because that's how we're comparing them. My p-value is less than alpha. Reject the null hypothesis. That's the method. And both of them come to the same conclusion. Reject that null hypothesis. Get it out of here.